I shall start the session. Actually, in the last class, we taught about what sound. Am I right? I have explained about sound, and also explained about some question. What is the velocity of the sound, and the sound is velocity depends upon what factors, and these all things I discussed. Am I right? So now, based on that, we'll do some questions today. Okay, now. So I'll share for you the questions. You have to try the answers. Understand? So the questions are I'll share for you. Yeah, now start doing. So start answering the questions. So look at the first question. Sound propagates from one point to another point. So what is the answers? Very good. So answer is what? Energy, already they kept the answer. Next one. The region of high density vibrating particle is called. The region of high density vibrating particle is called. Actually, the sound is propagating as a form of crest and trough, as well as high density and low density regions it will form when sound is traveling. The high density region, also known as a high pressure region. The high pressure region is called, what is the meaning of the, what is the name of the high pressure region? The high pressure region is also known as a what? Compression. Because look at here, when this is a sound source, for example, from the sound source the particles will be having one place dense particles. This is the way, at one region dense particle, another region less density, at another region high density, at another region low density, at another region high density. One low density, one high density, one low density, one high density, such a way that the sound is propagating by the particles of the medium. But where more density of the particle is, the region is known as a what? What is the region name? Compression. Next, same way, the region of low density vibrating particle is called. Tell me. Second, another one. What is the rare fraction? Very good. Across the rare fraction, you will have less density and less pressure. Across the high density, you will have high pressure. Understand? So next, sound cannot travel through. Very good. Why? Why sound cannot travel through vacuum? Give me the reasons. Because sound requires medium to propagate. Understand? Because sound is requiring medium to propagate, so that sound cannot travel through vacuum, because in the vacuum no medium is placed. Next, fifth one, choose the correct statement. Sound is a form of energy. Sound travels in the form of waves. Sound causes sensation of hearing. All the above statements are correct. So what is the answer? All the statements are correct. Understand? The same way, when sound travels through air, the air particles vibrate along the direction of wave propagation, vibrates but not in any fixed direction, vibrates perpendicular to the direction of the wave propagation, do not vibrate. Which one is the answer? When okay, I am asking one question. Tell me one thing. Sound is a what kind of wave? Longitudinal or transverse wave? Which one is correct? Yeah, mechanical and longitudinal. Kada? To why we are telling it is a mechanical wave? Because sound needs a medium. Sound requires a medium to travel, so that we are telling that it is a mechanical. But why we are telling that longitudinal? The vibrating particles are moving or vibrating in which direction? In which direction the vibrating particles are moving? The vibrating particles always move parallel to the wave propagation, means in the direction of the wave propagation. Since what is the option here? What is the C? See here, this is perpendicular kada. The particles cannot vibrate perpendicular to the wave propagation. The particles will vibrate in the direction of the wave propagation, parallel to the wave propagation. So what is the answer then? So what is the answer then? Option A is correct. Understand? Next, same way, other questions, let's see. Tell me now. The time taken for the vibrating particle is known as, time taken to the vibrating particle is known as, time taken to vibrating particle. Actually, why we are having the sound generally, we are having the sound or we are having the wave because of the vibration, because of the oscillations of the particles. So here, to complete one oscillation, something time it will take. The something time is known as time period actually. So here, what is the time period? Answer, the time taken for one vibration is known as what? Time period. So that is the answer. Same way, number of vibration per second is called, number of vibration per second. Very good. Frequency is a correct answer. Same way, the unit of frequency in SI system is, the unit of frequency in SI system is what? Hertz, we call it as a hertz. Actually, dyne is a, whose unit is dyne? Dyne is whose unit? Dyne is a force unit, but it is CGS. CGS unit of force is a dyne. So same way, what is Newton? Newton is a SI unit of force. What is second? Second is a SI unit of time, and hertz is a SI unit of frequency. So that is our answer. Next, the distance between any two successive equivalent point on the wave is called. Very good, wavelength. Simply, this is asking distance kada. Distance between, see, look at here. There is a no other option for the length. Only one option is there, that is wavelength. Understand? Next, the maximum displacement of a vibrating body from its mean position is known as maximum. Tell me, boss. Very good. So, for example, this is a particle. For example, this is a particle. When this is a particle, this particle is vibrating through and fro motion. This is the way the particle, this is a mean position, this is a extreme position, this is another extreme position. So particle is reaching to here and coming back to mean position and reaching to other mean position, other extreme position and reaching to mean position. So actually this total scenario to take time is time period, and this from here to here, this distance is known as amplitude. Understand? So this way we can have the answer. And next slide I will share for you. Yeah, this is your next questions, next slides. Is it appearing? Yeah, the unit of amplitude is, yeah, actually all the above. What is that? Sorry, centimeters, meters, both A and B, because the amplitude is nothing but distance. Understand? Amplitude is nothing but distance. What is the distance units? Distance units are centimeters and meters. Am I right? So, what is the answer here? Both A and B is our answer. Next, the relation between frequency and time period of a sound wave is the relation between frequency and time period. What is the relation between frequency and time period? Frequency is equal to, generally you will get this answer by using the definition of the frequency. Frequency is reciprocal of time period. So when a frequency is reciprocal of time period, the frequency is equal to 1 by t. Okay, and frequency is 1 by t. From here, t is equal to what you can write? 1 by frequency. So what is the option then? C. Very good. Same way, the speed of sound can be calculated by using. What is the formula for speed of the sound or speed of sound? Yeah, look at here. Generally, speed is equal to frequency into lambda kada. Already this formula is given. Here instead of n, I will take f. Instead of n, I will take f. Then what is the answer? Tell me. Option B. Yeah, Avinash, I have a question. Are you all right? But your voice is having very low, Babu. Okay. Take care. Understand? Your brother also having the same. Am I right? Yeah. Take care. Yeah, it's okay. Now next, the speed of sound is maximum. Which medium? In which medium the speed of the sound is maximum? Already, Amma? Solids. Already they kept the answer. And next, the speed of sound in air is. The speed of sound in air is. The speed of sound in air is 330 meter per second. The ratio of the speed of an object to the speed of sound in the surrounding medium is called. The ratio of the speed of the sound. See, they given this way. What is the speed of the ratio of speed of an object to the speed of sound is known as. So let me take something ratio. Speed of an object, speed of sound is known as actually something called k. The k is nothing but Mach number. Understand? That is a Mach number. Next, let's go for the. Just reset this questions. Yeah. Next, the relation between speed of sound and density of the medium. What is the relation between speed of sound and density of the medium? Actually here, this is the answer. So option D is the answer. Okay now. Next, the relation between speed of sound and temperature is. What is the relation between speed of sound and temperature? So directly proportional relation. Understand? Speed and temperature both are directly proportional relation. And next, the speed of sound in the gas. Speed of sound in the gas dash with increasing of humidity. Changes or decreases. What is that? Speed of sound in the gas with increasing humidity, increasing the speed of sound. So that is the answer. The speed of sound in gas dash with the increasing temperature, increases or decreases. The speed of sound in the gas. The speed of the sound in the gas by increasing the temperature, it will increases. Speed increases. So next, odd man out type questions. These are. So first one is time period, frequency, reverberation, amplitude. So tell me what is that odd man out here? Time period, frequency, amplitude. Actually, time period, frequency, amplitude is for vibration, and this is the thing. Reverberation is actually one phenomena. Reverberation is a phenomena. Time period, frequency, amplitude are the physical quantities, and reverberation is a phenomena. Okay, so actually reverberation is nothing but repeating sounds. Actually, understand, repeating the sounds continuously is known as a reverberation. Sometimes we call as it is a resound. We call it as a resound. Actually, to not to get reverberation in general, in the cinema theaters, in the banquet halls, or else in the auditoriums, they will take some precautions. The precautions are taken by the to not to get reverberation is nothing but usage of cushioned chairs. Next, the walls all fit with wood or cloth, and the top ceiling is also have that holes kind of ceiling. So that kind of precautions they will take to not to get reverberation. Understand? So that is a thing for the reverberation. So this reverberation is a phenomena. All other are physical quantities, since our answer is reverberation. Next, tell me now 23. Vacuum, solids, liquids and gases. Which one is the odd option here? Vacuum, because here this one are the mediums. So this is not a medium, this is a empty space, is known as a vacuum. So this is your answer. Next, density, temperature, humidity, wave velocity. Why temperature? Actually humidity. Sorry. Density, temperature, humidity will affect the wave velocity, and here wave velocity they are given. So what is the argument? It is wave velocity. Here also you can take humidity. This density, temperature, wave velocity are physical quantities, and humidity, it is not a physical quantity. It is a something act. Humidity is nothing but something act. Okay, thus happened thing is nothing but humidity. In the if the moisture content is increases in the environment, in the atmosphere, we can say the humidity increases. Since it is not a physical quantity, the remaining all are physical quantities. Understand? So that is our answer. Next, I will share one more slide for you. Yeah, see this. Is it appearing? Yeah. Propagation of wave transfers. Propagation of wave transfers. Propagation of wave transfers, both actually only energy. Propagation of wave transfers only energy. Actually, in general, to transport the energy or to distribute the energy, to move energy from one position to another position, the matter must be moved. But here, very advantage of the waves is nothing but without changing the position of the matter, we can transfer the energy one position to other position without changing the position of the position of the particles. We can transfer the energy from one position to other position. Understand? That is the advantage of what? A wave. But here, without wave, if it is not wave, how can you transport the energy? By changing the position of the masses, we can transport the energy. But the thing is, here energy can transfer without changing the position of the particles or without changing the position of the matter, we can transfer the energy from one place to other place. Okay, so the answer is here only energy. Next, the velocity of sound in vacuum is, already this question we done. Tell me the answer. Very good, 330 meter per second. Next, see, this is in vacuum kada. In the vacuum, will the sound travels? Sound cannot travel in the vacuum kada. So the answer is what? 0 meter per second. 0 meter per second is our answer. Okay. Next, a tuning fork, a violin string and a loudspeaker cone are producing sound. This is because they are all in the state of what? Very good, excellent answer. So they are all are in a state of vibration, so that they are producing the sound. But here I have one more extra question here. Tuning fork, it is vibrating. Tell me which part of the fork, tuning fork will be vibrate? The prongs of the tuning forks will be vibrate, so that will have the sound. Actually, it will not produce a bigger sound. If you keep the tuning fork near to your eardrum, then you will have that, you will experience that sound. Understand? In a similar way, here one more thing, a violin string. Violin string means if you have the violin, if you beat that strings of the violin, so that the vibration of the string will produce a sound. And same way, loudspeaker, also the loudspeaker having actually woofer, we call it as a woofer. If the woofer vibrates because of the magnetic induction inside the speaker, the woofer vibrates because of the diaphragm having experienced the magnetic forces, so that the woofer will vibrate. The vibration will produces the sound. Understand? So these are all the things about 27 question. Next, 28. The astronauts communicate with each other by radio telegraphy on the surface of the moon, because there is no air for the propagation of sound. The gravitational pull of moon is too small. It is too hot, too cold, and the surface of the moon, none of this. So what is the option here? There is no. The first option is right, because there is no air for the propagation of the sound, because on the moon surface we don't have the atmosphere. Why we don't have the atmosphere on the moon surface? See, the escape velocity of the atmospheric molecules is less, greater than the RMS values, so that the moon not having any atmosphere. Okay, that is the reason the sound cannot propagate through the vacuum, since they will use radio telegraphy. Next, a list of mediums is given by below. In which of these medium can sound travel? Tell me. In which of these mediums sound travel? Wood, water, air, vacuum. So in which medium sound will travel? So let's see the first question. First option 1 and 2 only. B option is 1 and 2 means wood and water. Even in the air also the sound travel kada. So the third option not given. B option is 1, 2, 3. So this is also travel. So see, so second option is right. Understand? Next, sound can travel through dash. Gases only, solids only, liquids only, solid, liquid and gases. Which one is correct? Very good. Next, the physical quantity which oscillates in the most wave is the physical quantity which oscillates in most of the waves? Oscillates. Oscillates is asking. The physical quantity which oscillate is mass. Mass will oscillate. Understand? Next, one of the following properties of the wave, the one that independent of the other is amplitude, velocity, wavelength, frequency. So this one is correct. Okay. Actually, velocity, wavelength, frequency are three depends on each other, but amplitude does not depend upon the remaining three, since the answer is what? Amplitude. So which of them has the highest amplitude? Tell me. Which of them has the highest amplitude? B or C na D na? See here, this C is having highest amplitude. So amplitude means from mean position to the maximum position we have to see. So option C shows the same thing. Understand? Next thing is there any other questions here? Yeah, no questions we have here. So I'll go for the next slide. So this is the next slide for here. Yeah, see here. No. Which of these has highest frequency? Which of these has highest frequency? A, B, C, D. Which one has highest frequency? Frequency means number of vibration per second. Here, who is having number of vibrations? Who is having number of vibration? Look at here. This D has number of vibration. When the particle having number of vibration, it will produce more wavelengths in 1 second. Okay, when a particle vibrate, number of vibration is more in 1 second, it will produce more wavelength in 1 second. Since this D option is providing more wavelengths in 1 second, since our answer is what? D. Next, 1 hertz is equal to 1 vibration per minute, 10 vibration per minute, 60 vibration per minute, 600 vibration per minute. So what is that? 1 hertz is equal to not 10, Babu, 60 vibration per minute. Actually, what is mean by frequency? Number of vibration in 1 second. Okay. For suppose in 1 second, if it is one vibration, then the frequency is what? 1 hertz. Understand? Same way, same thing we can explain with another way. In 60 seconds, 60 vibrations. Which means that in 1 second, how many vibrations? 1 second I am repeating. In 60 seconds, 60 vibrations. In 1 second, how many vibrations then? 60 seconds, 60 vibrations. Then in 1 second, how many vibrations? 1 vibration. 1 vibration. Here the same thing. 60 vibration per minute. Per minute means how many seconds? 60 minutes. Sorry, 60 seconds. Since this is your answer. Okay? And next, factors affecting the speed. Now, the speed of sound is solid and liquid gases are correctly compared. Which one is correct answer? Option A is the correct answer. Very good. The speed of sound in the medium depends upon. The speed of sound depends upon, look at here, the properties of the medium. Understand? The properties of the medium, it depends. Next, which of the following will remain unchanged when the sound wave travels in air and water? See here, frequency. Frequency of the sound never changes. So when it is traveling from when air and water. So the remaining things you can do, take as a homework. For now, I'll stop the session. Just I'll share for you the remaining questions. Yeah, you can take the screenshot of the remaining questions, try these answers. Okay. For today, I'll stop the section. In the coming classes, I'll explain some other part of the sound. Okay, now. For today, we'll stop the section. Okay, bye.